we'll read this one together. So do you see how it says write a model using slope-intercept form? That's what it says there. So just to think back, we had 3 forms of a line, and the goal in this equation, or in this particular problem, the goal in this problem is going to be to write an equation in the form y equals mx plus b. So let's go ahead and take a second to read it together. It says, in the school year ending in 1993, so this is an oldie but a goodie. In the school year ending in 1993, 2 million females participated in U.S. high school sports. According to the same study, by 2003, the number had increased to 2.86 million females. Write a linear equation that models the female sports participation. So that's part A. We got to write an equation, right? So we're going to write a y equals mx plus b in part A. And then in part B, it says use the equation to estimate how many females participated in sports in 2008. I see some of you circling and underlining. I'm assuming you're picking out the things that you know and the things that you don't. It's also a good idea to declare our variables. So we are going to have an x and a y, because we're writing a y equals mx plus b, right? I see 2 things varying in this problem. That's why I have 2 variables, by the way. 2 things changing in the problem. I'll do go ahead, Ashley, get it. Yeah, very good. So, did you hear? She says year and the number of girls, but she didn't tell me which one was which. And I had to put my other class today through their paces. So, years and the number of girls. So, which one's X and which one's Y, Darby?
X would be year and Y would be.
Yeah, very good. Okay, how did you know that? You're absolutely right.
I took the notes from Friday on this classroom and had this problem already done. And I put this in the notes.
Well, awesome. Okay, so remember that X is our control variable? Most commonly, right? So X is our control variable, or our inputs, or our domain in a function. The most common control variable we have anywhere on the planet is time. It is the biggest constraint. You only have so much time to do your homework. I only have so much time to make my money. I only have so much time to grow this bacteria in a petri dish. Time controls so much of what we do. And in this case, it is controlling, or it's the control variable in this study, right? What we see is the number of female participants in sports increasing over time. So time is our control variable. It'll be the denominator in our slope. Okay, and you said the other quantity was females, right? So Y will be our number of female athletes. And I'm going to say Y is in millions, because I care to not carry all those zeros around in the problem if it's all the same to you. Okay, so what I get out of this is basically when I read the problem again through this lens of X is time, Y is the number of females, is I get ordered pairs hanging out in the problem. For instance, I see in the year 1993, I have 2 million females participating in U.S. high school sports. So for me, my first ordered pair comes from that little gem of information right there. Now, I'm not going to use 1,993 as my X value. I'm going to say that that's year 0, because that's going to make life a little bit easier for me as the problem rolls along. And then the other piece of data they give me in the problem is 2003 and 2.86, right? But I'm not going to use 2003 as my time. This is time in years, right? So it's been 10 years. It took 10 years to get to 2.86 million. So what I have now is an X1 and a Y1, an X2 and a Y2. questions about how I produce those ordered pairs? You can't write a line without points, right? You need at least 2, so those are the 2 points they gave me. Okay, now I'm ready to write my equation. Last week, what is the first step when we have 2 points? Go ahead. You do have to find your slope, so I am going to go ahead and do my slope. y2 minus y1 over x2 minus x1. So I have 2.86 minus 2 over 10 minus nothing. And that's 0.86 over 10, which is 0.086. It said I have to write it in y equals mx plus b form. So I have my m. My m is just this 0.086. Now I need my b. But don't work too hard, kids, because I took a shortcut in the beginning of the problem that really helped me out here. Do you see it? I already have a b value. Remember, your b comes at you in the form 0, comma b, 0, comma a number. So I found my y-intercept by starting this model at year 0. So my b value is actually 2. It's kind of nice. It's a nice feature. You know, you could, if you were doubting me, you could do point slope form and use this other point here. You're going to get the same answer. It's going to work out. But hey, let's do math the easy way today. How about that? So the answer to this one is going to be y equals 0.086 x plus 2. So that's that first part of the problem done. Okay, now in part B, it says use this equation to estimate the number of females participating in sports in 2008. So they're giving me an x value because they're giving me time. 2008 is a time. But I tweaked my x values a little bit.
Would you do y equals 0.086 times 5?
Not times 5.
Times 15.
Times 15, because you have to go back to the y-intercept. Yeah. So we are going to, because 2008 is 15 years away from 1993, in this problem, we're going to let x equal 15. Because that would be the year 2008. The model starts in 1993. So we're going to go ahead and plug and chug a little bit on our calculators. Let our x value equal 15. And when I work this out, I got about 3.29. But we got to be careful. Usually word problems you want to answer in some sort of sentence. And if I just go by the number, what I'm learning is that, like, well, if I just use 3.29, it's like 3 1/3 females participated in high school sports in 2008. So leaving it just like that doesn't quite make sense. I have to add a little bit to it, right? So this is actually in millions, right? So we could say that, you know, in 2008, approximately 3.29 million females participated in high school sports. That would be our answer right there. In 2008, approximately 3.29 million females participated in high school sports. What's up?
Okay, so on the part B, I wonder why can't you go from, if you're using the equation from 1993 to 2002, why can't you use
5.
the 5 years?
Okay, good question. So, it goes back to how you define your x. So we said it was going to be a number of years, and I guess in parentheses I probably could have added since 1993. That's kind of common in how you'll see that. if we let x equal 5 in this problem, we're actually getting the year 1998 by accident. You know what I mean? It's only 5 years from when the model started. So we're letting x be a number of years since 1993, and that's why we can't. And again, like 5 is that number that's between 0 and 10, and that's how I knew I was going to be landing kind of in between there. Any other questions? Okay, dokes. All right, brand new topic for the day is actually not really new. You did this topic last in your pre-algebra, Algebra 1 class, so it's probably been a while. The final topic in this section that'll be on your quiz tomorrow is this topic of direct variation. Save a little vocabulary to write down there. I'll read it so you can see it here. All right. Direct variation. Direct variation is the equation y equals ax. The equation y equals ax represents direct variation between x and y. So first part of that definition, the equation y equals a times x represents direct variation between x and y. Second part, and y is said to vary directly with x. This sentence right here is in any word problem where you're asked to use direct variation. If you don't see the phrase varies directly, you're just doing your regular y equals mx plus b. So when you see varies directly, I need you to think about direct variation. And you're writing an equation y equals ax. The graph is going to be a linear equation that passes through the origin. Repeat that definition one more time. Definition for direct variation is the equation y equals ax represents direct variation between x and y. And y is said to vary directly with x. The graph is going to be a line, or a linear equation, that passes through the origin, which is the point 0, 0. In order for something to be modeled by direct variation, there must exist something called a variation constant. You're probably wondering what that is, so let's define that real quick. It says the non-zero number for a in the equation y equals ax. So what does that mean? It's your slope, people. What you're going to notice over the next couple of chapters, your book is like, phooey on the letter M, and they pop in an A instead. And that's going to work out for us for a couple of chapters. So what you're starting to observe is the idea that, yeah, y equals ax is a linear equation. So it was like our y equals mx plus 0. So our graph passes through the origin because it has a y-intercept at 0. And then they're just basically swapping out your a and your m. So a and m for the rest of this chapter are basically the same. Slope and your a value are the same. So your variation constant is your slope in the equation y equals ax. And to find your variation constant, all we ever have to do is just divide our y values by our corresponding x values to see if that variation constant exists. So here's what I mean by that last part. Take a look at example 6. I'm supposed to figure out, does that table show direct variation? So what am I responsible for doing? The entire chart, I have to divide y by x. Divide y by x, divide y by x, divide y by x, divide y by x. And I should get the same number each time. So right now I'm checking to see if there exists an a value. And to do that, I'm going to take y and divide it by x, 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 y and divide it by x. And I'm asking myself, are these all equal to each other? And when I look at these fractions, I'm like, wait a second, that reduces to negative 1/3, and that reduces to negative 1/3, and that reduces to negative 1/3. Oh yeah, and this reduces to negative 1/3. So there exists a constant of variation, aka a variation constant. People, constants are things that don't change, right? So I got negative 1/3 each time it did not change, which means this is direct variation. So our A value is just negative 1/3. So I could use this now to write a direct variation equation. I just swap out my slope. Oops. That's not supposed to be an A there. That's supposed to be an X. So it's y equals negative 1/3 X as my equation. That's this part of the problem right here. Write an equation that relates X and Y. So I had to write my equation of the form y equals AX. That's what I did there. Now, one more test to see if something is direct variation. You could graph this t-chart real quick and just make sure the line would pass through the origin. So I'm just taking a second to plot the points that were on my graph there. And I do know that if I repeated this pattern in reverse, I would get a graph that certainly does, went a little farther, that certainly does pass through the origin. See, it passes through 0, 0 there. And our slope, or in this case, our A value is negative 1/3. So we could say, yes, this is direct variation. And that's just, again, going back to the definition. It's a line that passes through the origin. So let's take a vote. We're trying to decide, is the equation direct variation? So let's take a look at part A. Y equals 8x. Is it of the form y equals a times x is what we're trying to figure out. Who says yes, that is direct variation? Good job, it is. Okay, wait, I'm not done. Yes, that is direct variation. Can anybody tell me the variation constant in that equation? Yeah, 8. It's like our slope, right? Okay, part B. Y equals 8 divided by x. Is that direct variation? Who says yes? Good job. It is no. Nobody raised their hand. No. This is actually what we call inverse variation. And it's the result of, I could pretty easily turn this equation by multiplying both sides by x. This would be xy equals 8. So if you multiply the values in your t-chart together and get a constant, that's the case where you get inverse variation. We'll do this in chapter 8. So that's a preview of coming attractions. Makes a hyperbola. All right, last one, part C. This time I decided to add 1 onto my 8x. Who said yes, that is direct variation? Who says no? Wow, good job. All right, why? It is a function, but direct variation is a function too. They've all passed the vertical line test. What do you think, Parker? It's slope-intercept form. In other words, I think what you're saying, my man, if I understand you correctly, this passes through the point 0, 1. What does direct variation have to pass through? The origin, 0, 0, yeah. So we can't have a y-intercept tagged on to the end and have that be direct variation. So this is no. This is just a good old linear equation or linear function. It's not in that special category of direct variation. Last problem of the day, we're going to apply this business. Oh, word problem, word up. This is actually pretty interesting. Hooke's law, I don't know if you ever looked at it at all, but it's just basically affiliates the distance you can stretch a spring, and that distance varies directly based on the force or the weight applied to it. So here in example 8, we have Hooke's law states that the distance d of a spring varies directly, there it is, kids, with the force that is applied to it. So that lets me know I'm not doing a y equals mx plus b, I'm doing a y equals a times x. And I always build my equation just by looking at the order in which the letters appear. So my first letter in the equation is D, because that appeared first on my paper. So I have D equals, and when it says varies directly, yep, that's my cue to pop the A in there. And then the last letter in the problem is an F. So literally I can read this as distance varies directly with force in pounds. That's what that means. And it says in part A, suppose our string stretches 15 inches when a force of 9 pounds is applied. Write an equation that relates D to F. Well, I almost have my equation. I just need to figure out what this A value is. So I'm going to go ahead and take a second, fill in my distance, and force, solve. Is 5/3. Not done though. It says write an equation that relates these two things, so I have to do D equals 5/3 F. So that's that. Okay, next it says use our equation to predict the distance that the spring will stretch when you apply a force of 6 pounds. So I'm going to go ahead, it says force of 6, so they're saying, hey, in this problem, take your equation and let F equal 6. I'm going to do that. D equals 5/3 of 6. I'm going to cross reduce. This is 10 inches. There's my answer there. So if I hook a 6-pound weight onto the bottom of that spring, it's going to stretch 10 inches. That's what that's saying. You have a conclusion question at the bottom there. Without peeking to the top of the paper, I want you to answer. What is direct variation? We learned at least 3 things today. At least 3 bullet points underneath there. That's what I'm looking for. Try to do it without peeking at your definition. I'm going to walk around and check off your homework.